All right, this video is to go over again just some problems we worked out in class to help with that equations from graphs worksheet. Now there's two types of problems on here. There's some that are tangent and cotangent. Well, those look like this, these like number 1, number 2, number 3, number 8. Those ones that look like that, those are tangent cotangent graphs. The other ones with all the parabolas like 4, 5, 6, and 7, those are secant cosecant graphs. So let's just pick one of each. Let's say we work on number 3 here. So you look at this is a tangent cotangent graph. Now it's already drawn in for you. On a tangent cotangent, the first thing I would do, you see this dotted line that's up here at 3? That line goes right through the axis points. I think I would draw that line very first thing. So find the axis points. They're right in the middle between the asymptotes. Draw an axis line right through there. Because one, that tells you what your vertical shift is. So here, that distance from the x-axis up to there is 3. So this one, our vertical shift is 3. Now, amplitude for tangent and cotangent is always either 1 or -1. It's so hard to tell here exactly where it's at. So it's always either 1 or -1. You would use 1 almost all the time. If you decide you needed to flip it over to invert it, then you would just use -1. So that's when you would do that. All right. Then for our period, you can do it a couple ways. One, you can go asymptote to asymptote. That's a period. Or you can do axis point to axis point. That's a period. Either one works fine. Let's say here, it looks like here we have an axis point right on the y-axis. And here we have one at pi. So that means here our period is just pi. So to find our angular velocity, remember we take the normal period, which for tangent is pi, divided by the new period, which is pi. So here our angular velocity is just 1. That's 3 of our things. Now for the fourth thing, the horizontal shift, that depends on whether we choose to do this with tangent or cotangent. Now most of the time on this one, I would probably use tangent because it's going uphill. Tangent goes uphill. So if we use tangent, then we'd think of the starting point. Tangent starts with an axis point. Well, notice there's one right here on that y-axis. There's one over here at pi. There's one over here at -pi. We could use any of those. Since there's one on the y-axis, you could use 0. You could use pi. You could use -pi. All of those work fine. So now if we start our equation, y equals our amplitude, which we said was 1. I'm going to put it there. You don't have to put it there when it's 1. Tangent. And then if we use this, that'd be x minus 0, which could just be x. If you used pi, this would be x minus pi. If you use -pi, this would be x minus a -pi. So any of those 3 are good for that part. And then plus our vertical shift, which was 3. So any of those 3 equations work fine. Instead of x, you could have x minus pi. Instead of x, you could have x plus pi. Now you could have also done this with cotangent. There's 2 things different. First, for cotangent, it starts with an asymptote. So we look at where there's an asymptote. So our horizontal shift looks like there's an asymptote here, right in the middle, that's at pi over 2. Looks like there's another one over here at -pi over 2. So we could use either one of those. For our amplitude, since cotangent normally goes downhill and these go uphill, I would use a -1. So if we were using cotangent, we'd say y equals -1 cotangent. Our angular velocity is still 1. Now we have either x minus pi over 2, or we could have used x plus pi over 2. Either one of them gets us okay. And then our vertical shift is still 3. So the only thing that changed was our horizontal shift, and we changed our amplitude because we had to flip it over. So that's how you do tangent and cotangent. Let's look at a secant cosecant one. Like let's say we look at number 7. Now number 7, first, you could find the vertical shift and the amplitude from max and mins. Remember, we have an equation that says vertical shift equals max plus min divided by 2. Well, here our max is an up parabola. Well, there's an up parabola at 2. Our min is our down parabola. There's a down parabola at 0. So our vertical shift is 1. For our amplitude, we do max minus min divided by 2. So that's the same numbers. The up parabolas are 2. The down parabolas are 0. Only now we subtract, which still gives us 1. So we got those two things. The next thing I would do, and this is already here for you, is right in the middle between those up parabolas and down parabolas, I would draw an axis across here. You can see they already have one for you. I would draw that in. The next thing I would do is I would draw in a sine or cosine curve. These spots where a vertical asymptote crosses the axis, that's an axis point. Right here, axis point. Here, asymptote, axis, axis point, axis point. So those are all axis points. Then if we draw it in, well, this is a crest. So we're going to go up to a crest and down. This is going to be a trough and back up. There's another crest and back down. There's another trough. So if we sketched in a curve, it would look like that. I think that helps us with two things. I think it makes it a little easier to see the period, and it definitely makes it easier to see the horizontal shift. First of all, the period. We know when we look at sine or cosine, period is like crest to crest or trough to trough. So we could do that here. Here's a crest at negative pi and another one at positive pi. Well, the distance from negative pi to positive pi is 2 pi. Or if we use troughs, here's one at 0 and one at 2 pi. That distance is 2 pi. So that's our period. Now remember, for angular velocity, we take the normal period, which for secant and cosecant is just like sine and cosine. So that's 2 pi divided by our new period. So our angular velocity is 1. Right? The last thing is our horizontal shift. And this depends on whether you choose secant or cosecant. I tend, if I have a choice, to use secant. If we use secant, remember, for secant, we pretend we're doing cosine. Well, think of starting point. Cosine starts with an amplitude. So look here, where do you see an amplitude? Well, I see one over here at negative pi. There's a crest, so that's an amplitude. I see another one over here at positive pi. So either one of those could be our horizontal shift. So if we start our equation, y equals our amplitude, which we said was 1. If we use secant, our angular velocity is 1. Then in parentheses, we can either have x minus a negative pi or x minus pi. Either one of those is correct in here. And then plus our vertical shift, which was 1. So that's the equation if we use secant. Again, I like secant just because I think it's always easy to find a crest. If we chose to use cosecant, everything's the same except our horizontal shift. Now, cosecant is reciprocal of sine. So where does a sine curve start here? Well, wouldn't this be the start of a sine curve? Because then it start here and go up and down like that. So that could be a starting point. That looks like negative 3 pi over 2. You could say right here is the start of a sine curve. Because there it starts on the axis, it goes up and then down. So that looks like it's pi over 2. So we can use either one of those. So we do the same thing. Y equals the cosecant. Our amplitude was 1. Our angular velocity is 1. So now we either x minus a negative 3 pi over 2, or we could have put x minus pi over 2, and then plus our vertical shift, which is 1. On this one, you could actually use cosecant and a negative amplitude. I'm sorry, you could use secant and a negative amplitude. Because notice, there's a trough right here on the y-axis. Remember, when does cosine start with the trough? When the amplitude's negative. So we could have done secant and said y equals, make it a negative secant because we're flipping it over. The angular velocity is still 1. Now there's no horizontal shift, so it's just x plus our vertical shift. So that would have been a correct answer also on that one. Sorry, I didn't see it. So y equals the negative amplitude because we're starting with the trough. Secant of x. There's no horizontal shift because our trough is right on the y-axis, plus 1. That's just a little help. Those are some problems we did in class on Thursday on those.